Okay. Why is that not up on the right screen? There we go. Here's what I want you guys to spend the first 2 minutes of class now doing. 2 minutes if you need it. Which periodic functions, these are our trig functions, are even, which ones are odd, which ones are neither. This picks up right where we left off yesterday. Which ones are even, which ones are odd, which ones are neither. Mm-hmm. Okay, wonderful, thank you. All right, okay, bye. Which ones of our 6 trig functions are even? Cosine. And if cosine is even, what else would have to be even? Secant. Cosine and secant are even. This means that they have what type of symmetry? Y-axis symmetry. This means if I have the cosine of a negative number, a negative angle, it is exactly the same as what? Cosine of when it's positive. Think about other even functions you guys know. Think about a parabola, y equals x squared, right? If you put 2 into that function, what's 2 squared? 4. What about if you put negative 2 into that function? 4. It doesn't matter whether you put the positive in or the negative in, you get the same result. That's exactly how cosine and secant work because they're even, just like parabolas are. What about odd? Sine and tangent. And if sine and tangent are odd, what else would have to be odd? Cosecant. And what else? Cotangent. Since they're odd, they have what kind of symmetry? Origin symmetry. So when I'm thinking about sine of a negative value or tangent of a negative value, I want you to think about other things that you know of that have origin symmetry, like a cubic function, right? Y equals x cubed has origin symmetry. What do you get if you put 2 into y equals x cubed? What is 2 cubed? 8. What is negative 2 cubed? Negative 8. If you put the negative in, you get the opposite result, right? These work exactly the same way. So if I have sine of a negative angle, That's exactly the same as negative sine of the angle. I'm going to have to scoot that over a little bit. Negative tangent. Just like if I know what x cubed is, 2 cubed is 8. So negative 2 cubed would be negative 8. Does that make sense? Works exactly the same way, even in odd functions. So we're going to build off of what you guys already know. What falls under the neither category? Kind of a trick question. None of them. None of them fall into this neither category. All right. I want to take this idea of even and odd, and I want to use that to simplify some things, to find some values. So I want you guys thinking about your unit circle. Most of class today, most of the rest of 6.3 and 6.4 that we're going to dig into, this is all getting you ready for that unit circle quiz tomorrow. All right. Sine of negative 45 degrees is exactly the same as what? Is sine even or odd? Odd, which means it's the same as negative sine of 45 degrees. So if I know what the sine of 45 degrees is, I just pop a negative in front of it and I'm good, right? Let's do the ordered pair for 45 degrees. What is my ordered pair, my x and my y? Close. Those are my over 3s and over 6s. That's okay. The over 4s, square root of 2 over 2. Yep. When I'm looking at an ordered pair, which one is the sine? Which one is the cosine? Sine is y, cosine is x. Do you guys know how I finally memorized that? It took me forever. I kept getting them mixed up. You know how in our ordered pairs it's x and then y? And that's alphabetical order? This is alphabetical order. C comes earlier in the alphabet than S does. Same thing. So sine of negative 45 degrees would be what? Yes. It'd be negative root 2 over 2. Is secant even or odd? Even. So secant of negative 30 degrees is exactly the same as what?
Secant of negative 30 degrees.
Close. Secant of just 30 degrees. Yep. It's an even function. We have y-axis symmetry, so if I put the negative in, it's the same thing as if I put the positive in. So I want to think about my ordered pair for 30 degrees. Any of your degree markings that end in a 5, those are like your pi over 4s, right? 30, 60, 120, 150, if they end in a 0 and they're not the x-axis or the y-axis, these are your over 6s, over 3s when you think about your pi's, your radians. These are the ones that one part of the ordered pair is going to be root 3 over 2. Everybody's over 2 all the way around. One of them will be root 3 over 2, the other one will be 1/2. You decide which is which based on what axis you're closer to. Which one's bigger, square root of 3 or 1? Square root of 3 is bigger. Because if I do a square root of 3 in my calculator, I get 1 point something, right? Square root of 3 is bigger. Whatever axis I'm closer to, that's the one that gets the root 3 over 2. So 30 degrees. Here's my positive x-axis. 30 degrees is right here. Am I closer to the x or the y at that point? Closer to the x. So the x is root 3 over 2. And so the y would have to be 1/2. When we're talking about secant, which part of the ordered pair do I want to look at? I want to look at the x, because here's my cosine. So secant of 30 degrees would be what? 2 square root of 2 over 3. Sorry, we want secant of negative 30 degrees. 2 square root of 3 over 3. Flip it over, rationalize your denominator. How are we doing? Me? I can live with that. Is tangent even or odd? Odd. So tangent of negative pi over 6 would be the same as what? Negative tangent of pi over 6. Let's do our ordered pair for pi over 6. Pi over 6s, any of your pi over 6s, those are going to be the ones that are closer to the x-axis, because you've taken something and cut it into 6 parts across the top. Your pi over 3s are the ones that are closer to the y-axis. So my ordered pair for pi over 6 would look like what? Yes, square root of 3 over 2 and 1/2. In fact, pi over 6 is 30 degrees, right? That's exactly the same. I want tangent. How do we find tangent? Sine divided by cosine. So y over x. Do I have to worry about the denominators when I do that? No. So I'm going to have tangent of negative pi over 6. I'm going to do y over x, which would technically give me this, right? Negative because tangent is odd. How do I write that with a rationalized denominator? Root 3 over 3. So negative root 3 over 3. One more on this. Is cosine even or odd? Cosine is even. So cosine of negative 5 pi over 6 is exactly the same as what? Cosine of 5 pi over 6. Let's do our ordered pair for 5 pi over 6. Are the pi over 6s closer to the x-axis or closer to the y-axis? Closer to the x. So what's my ordered pair look like? Negative root 3 over 2 and 1/2. Because I'm past the halfway point, right? I'm getting real close to pi. So what is cosine of negative 5 pi over 6? Negative square root of 3 over 2. Five pi over 6 is in what quadrant? Second quadrant. So if I have a negative angle, I'm going which way? Going clockwise, right? Around the unit circle. Negative 5 pi over 6 would be in what quadrant? Third quadrant, right? Second quadrant, third quadrant. Cosine's negative in both of those. So far, so good? I want to look at a couple verify problems with you, and then we're going to move on to something called reference angles. I want to use what we know about negative angles, even and odd, to simplify these. You're only allowed to mess with one side at a time. We're going to transform the left-hand side to look like the right-hand side. Is sine even or odd? Sine is odd, so this would be negative sine x. Times, is secant even or odd? Even, so what would this be? Just secant x. Can I rewrite either one of those? Yeah, secant is 1 over cosine. And I'm multiplying that by negative sine x. Where to from here? Yep, I can write it as one single fraction. Negative sine x over cosine x. And sine over cosine is, that is the definition of tangent. So this would be negative tan x. What do I have on the other side? Negative tan x. Left-hand side equals right-hand side. Nice work. Let's do this guy. Is cotangent even or odd? Cotangent is odd. So how do I rewrite that numerator? Negative cotangent of x. Is cosecant even or odd? It's odd because it's a reciprocal of sine, right? So this would be negative cosecant x. What happens when you have a negative divided by a negative? That is a positive. So I have cotangent x over cosecant x. But we just said cosecant x was the reciprocal of what? Sine. So if I have cosecant in the denominator, how can I rewrite it so that it's not in the bottom anymore? If it comes up to the numerator, it becomes sine. It becomes sine. I'll write down the steps so those of you that didn't follow what I just said can see it. Cosecant is 1 over sine. If I want to get a fraction out of my denominator, I multiply by the reciprocal, right? So I would have cotangent x multiplied by the reciprocal. That'd be sine x over 1, right? So I'd have cotangent sine. I want to get this equal to cosine. How can I do that? Tell me anything you see that I can do. Yes, cotangent is 1 over tangent, but it's also cosine over sine. So I can rewrite this as cosine x over sine x, and I'm multiplying that by sine x. What's going to happen? Cancel the sines, and we are left with cosine x. That's what I had on the other side this whole time. Left-hand side equals right-hand side. Let's do one last verify problem. We're going to take everything on the left and simplify it to what? What are we going to get it to simplify to? What's my right-hand side? Cosine. Everything on the left, we're going to be able to simplify to be cosine. Is cosine x even or odd? even. So I can rewrite this as just 1 over cosine. Minus, is tangent even or odd? Odd. So this would be negative tangent of x. We're multiplying that by sine of negative x. Is that even or odd? Odd. Negative sine x. Oh my goodness. I have a negative times a negative, which gives me a positive times another negative. So it's negative again. So I have 1 over cosine x minus tangent x sine x. What can I do? Instead of tan, I can write that as sine over cosine. We're multiplying that to sine, right? So how can I simplify that idea? How do I multiply those together? It's going to become sine squared. Sine squared x over cosine. So I have 1 over cosine minus sine squared over cosine. I can make it all one fraction. I already have a common denominator there. So I have 1 minus sine squared x over cosine x. What do you guys know about this right here? That equals cos squared. So I have cosine squared x over cosine x. Yeah, one of my cosines is going to cancel, leaving me just cosine x. Cosine x equals cosine x, left-hand side equals right-hand side. That is the official end of 6.3. 6.4 is talking about the value of trig functions. We're going to start with a discussion of what's called a reference angle. And then after that, all we're going to be doing is talking about values on the unit circle. Getting you ready for your quiz tomorrow. All right, so values of trig functions. When I talk about reference angles, we represent this with theta r. The r means reference. It is an acute angle. What does that mean? Less than 90. So we're looking for some angle that's smaller than 90, where the terminal side, what's that mean? Terminal side? Where it stops. Yeah, where it ends. Positive x-axis is always my initial side. Terminal side is wherever we stop. So this is the acute angle that the terminal side makes with the x-axis. I'm always going to be making an angle with the x-axis. So for example, if I'm in quadrant 2, this right here is my reference angle. This would be theta r. Do you see how what I have outlined in purple is an acute angle? And it makes that angle with the x-axis. I can find that reference angle. I can find theta r by taking 180 degrees minus whatever theta is. So if theta is 135, I do 180 minus 135. What about if they give me theta in radians? Yeah. Then I would do pi minus theta. If my angle is in the first quadrant, does it already form an angle with the x-axis? Yes. Is it an acute angle? If it's in the first quadrant? Yeah, it'd have to be less than 90. In this case, my reference angle is exactly the same as my original angle. Theta r is just equal to theta. If it's in quad 1, I don't do anything special. Theta is my reference angle. If I'm in quad 3, this right here is my reference angle. It's an acute angle. It forms that angle with the x-axis. My reference angle, theta r, would be equal to whatever my angle is minus 180. Because in this case, if I go past 180, then my angle theta is bigger, right? So to find the acute angle, I'm going to do my big angle theta minus 180 to find out what that acute angle is. What about if they give it to me in radians? Theta minus pi. And last but not least, if I'm in the fourth quadrant, then this would be my reference angle, theta r. To find theta r, I'm going to do a full rotation. What's a full rotation? 360 minus whatever theta is. What about if I have radians? 2 pi minus theta. Yes. All right. I want to practice finding some reference angles with you, and then we're just going to do some unit circle values. That means as we're looking at these, I need to know what quadrant I'm in so I know how to find my reference angle. (225 degrees). What quadrant would that be in? Third quadrant. Is that bigger or smaller than 180? Bigger. So to find my reference angle, theta r, I need to do my angle, 225, minus what? Minus 180. What is 225 minus 180? How much? 45. What quadrant is 165 in? Second quadrant. Bigger or smaller than 180? Smaller. So how do I do this one then? If I do 165 minus 180, I'll end up with a negative. 180 minus 165. My reference angles should always be positive. Yep, 15. If you do it the wrong way and you get a negative, just take the negative away and make it positive. You want the acute angle. So theta r is 15 degrees. 2 pi over 5. That's not on my unit circle, but I should still be able to figure out what quadrant I'm in. First quadrant. How do you know?
Because 2.5 pi over 5 would be like 90 degrees. So
Yes. This is pi over 2. That's half pi. That would be 2.5 pi over 5. So if it's smaller than that, it has to be in quad 1. So that would be like here-ish. So what is my reference angle? Yep, 2 pi over 5. Last one, 12 pi over 7. What quad? Fourth quadrant, because it's almost 2 pi, right? Theta r is going to be equal to 2 pi minus 12 pi over 7. How can I rewrite 2 pi so that it has a denominator of 7? 14 over 7. 14 pi over 7 minus 12 pi over 7. So what is theta r? 2 sevenths. 2 pi over 7. Let's do some unit circle practice. And this, by the way, is all we're doing in 6-4. We're moving on to 6-5 tomorrow, because this is it.
Like just the reference angle thing routine?
Reference angle things is part of 6-4. And then other than that, it's just unit circle values. Let's do a couple of these. I want to know my ordered pairs for these. What is the ordered pair for 2 pi over 3? Negative 1/2 root 3 over 2. For those of you that are still struggling with the radians, here's how I do my over 3s, and we'll talk about the over 4s in a minute. My over 3s, I'm taking the top half and cutting it into 3 parts. So here's 1, here's 2, there's 3. So pi over 3, 2 pi over 3. This would be 3 pi over 3, which just reduces down to pi. And then I take the bottom half and I cut it into 3 parts. But I keep counting 1 pi over 3, 2 pi over 3, 3 pi over 3. So down here would be 4 pi over 3, 5 pi over 3, and I end over here at 6 pi over 3, which reduces. So as you're going around your unit circle to do your over 3s, you're going to be by the y-axis. 1, 2, stop here, do 3, 4, 5. So what's the sine value of 2 pi over 3? Root 3 over 2. Because sine is the y value. Let's do our ordered pair for 7 pi over 4. Any of your over 4s, both parts of the ordered pair are identical. So we only have to worry about the signs. All of your over 4s have what in the ordered pairs? Square root of 2 over 2. Seven pi over 4 is in what quadrant? Fourth quadrant. So who's negative? Y is negative. So what's the cosine of 7 pi over 4? Square root of 2 over 2. Here's how I count my way around the unit circle for these over 4s. The over 4s are going to take each of my quadrants and cut them in half. So I take the top half of the circle, I cut it into 4 parts. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Then I take the bottom half. I bisect those quadrants. Keep counting. 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. What do you notice about all the pi over 4s that don't reduce? They're all odd. 1, 3, 5, 7. 1, 3, 5, 7. As you move around, it bisects the quadrants, count by odds. Pi over 6, 7 pi over 6. What would be the ordered pair for that? What do you say? Yes, negative root 3 over 2, negative 1/2. So is the tangent going to be positive or negative? Positive. Tangent is what over what? Sine over cosine, y over x. So it's going to be negative 1 over negative root 3, right? Y over x, sine over cosine. Rationalize that denominator for me and simplify. Square root of 3 over 3. Let's talk about counting the over 6s. We would take the top half of the circle and cut it into how many pieces? 6. Which means each quadrant gets cut into how many pieces? 3. 1, 2, 3 pi over 6, 4, 5, 6 pi over 6. These will be the only ones that don't reduce. 1 pi over 6, 2 pi over 6 is going to reduce, 3 pi over 6 is going to reduce, 4 pi over 6 is going to reduce, but 5 pi over 6 will not. And then we would have 6 pi over 6, which reduces. Keep counting. What's my next numerator? 7 pi over 6. That's not going to reduce. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. That one does not reduce. And 12 pi over 6. Don't stop and write all of them. Only write the ones that don't reduce. But it helps to memorize if you just count that numerator around. 1 pi over 6, 2, 3, 4, 5 pi over 6, 6, 7 pi over 6, 8, 9, 10, 11 pi over 6. If you count that numerator, especially with your radians, it will help you write it down faster. All right. I want to do a couple of these that are in degrees. So let's go look at some degrees ones. What would my ordered pair for 150 degrees be? Close. Remember, if it ends in a 5, it's the root 2 over 2s. That's okay. Hold on. What quadrant are we in with 150 degrees? Second quadrant. Closer to the x-axis or closer to the y-axis? Closer to the y? Closer to the x. If I'm closer to the x-axis, who's bigger? The x. So this would be negative root 3 over 2 and 1/2. So what is the sine value? 1/2. Cosine of 90 degrees. What's my ordered pair for 90 degrees? 0, 1. What's my cosine? 0. Tangent of 0 degrees. What's my ordered pair for 0 degrees? 1, 0. Tangent is what over what? 0 over 1, so this is going to reduce to 0. Please practice tonight that unit circle practice quiz. Again, that closes at midnight tonight. I will not reopen it because your quiz is tomorrow. You've got to practice tonight so that you have the speed for tomorrow. You are welcome to grab a unit circle practice page if you want, so that you can practice writing it down by hand. By the way, tomorrow your unit circle quiz is literally that paper. It's not going to be a different paper. It is that paper right there. Same exact paper. I know on these practice pages it says positive, negative stuff. You don't have to fill that in on the quiz. You have to fill in 3 things in 3 minutes. Degrees, radians, ordered pairs. 3 minutes. All the way around. All right. 6-3 homework is also due tonight. That will help you with the unit circle as well. The 6-3 homework, the unit circle practice quiz, both of those will prepare you for the unit circle quiz tomorrow. All right? Please make sure you get those turned in to me. Let me know if you have any questions. 6-3 homework does not close tonight, but the practice quiz does. And I will be putting it into Skyward. So if you want points, please make sure you get it done.